First problem, show that the random process x of t, which is equal to a cos omega naught t plus theta, is wide sense stationary, that is WSS, if a and omega naught are constants and theta is uniformly distributed random variable. Solution. Given x of t is equal to a cos omega naught t plus theta, and theta is uniformly distributed in the open interval 0 to 2 pi. We know that the probability density function of uniform distribution is defined in the open interval a b is given by f of x is equal to 1 by b minus a, where x lies between a and b, 0 otherwise. Here theta is uniformly distributed in 0 to 2 pi. So here the PDF is f of theta, which is equal to 1 by 2 pi minus 0. Instead of b we have 2 pi, a we have 0. It is theta lies between 0 to 2 pi, 0 otherwise, which is equal to 1 by 2 pi. Theta lies between 0 to 2 pi, 0 otherwise. This is equation number 1. Next, we have to prove this is a wide sense stationary, that is WSS. For that, first condition is expected value of x of t, that is mean of the given random process x of t, is a constant. Second condition, the r xx of tau, that is equal to is a function of tau. These are the two conditions. So first we have to find the mean E of x of t. We know E of x of t, which is equal to, for a continuous distribution, 0 to 2 pi x of t f of theta d theta. So substituting the value of x of t and using the equation number 1, we will get integral 0 to 2 pi a cos omega naught t plus theta into 1 by 2 pi d theta. Here a, capital A, and 1 by 2 pi are constants, so taking outside the integral, so a by 2 pi integral 0 to 2 pi cos omega naught t plus theta into d theta. We know integral cos at plus theta d theta, which is equal to sin at plus theta. Using this formula, we will get a by 2 pi sin omega naught t plus theta, lower limit 0, upper limit 2 pi. Substituting the limits, a by 2 pi into sin omega naught t plus 2 pi upper limit minus sin omega naught t plus 0, the lower limit. A by 2 pi sin, we know sin 2 pi plus x, which is equal to sin x. So here sin 2 pi plus omega naught t, which is nothing but sin omega naught t, minus the second term sin omega naught t. So sin omega naught t minus sin omega naught t, which is equal to 0. So 0 into a by 2 pi, that is equal to 0. Therefore, expected value of x of t is equal to 0, is a constant. This is equation number 2. Now we need to find r xx of tau. So we know the formula r xx of tau, which is equal to expected value of x of t into x of t plus tau. So x of t, we know the values. So x of t a cos omega naught t plus theta. So expected value of, we are substituting the x of t value a cos omega naught t plus theta. Second one, x of t plus tau. So replace t by t plus tau in x of t. So we will get a cos omega naught into t plus tau plus theta, which is equal to expected value of a cos omega naught t plus theta into a cos omega naught t plus omega naught tau plus theta, removing the inner bracket, which is equal to a into a square. So cos omega naught t plus theta into second term cos omega naught t plus cos omega naught tau plus theta. So this is in the form of cos A into cos B. So we are going to use the formula cos A into cos B, which is equal to 1 by 2 cos A plus B plus cos A minus B. So here A, which is nothing but omega naught t plus omega naught tau plus theta, and B is nothing but omega naught t plus theta. So we will get the expected value of a square half into cos omega naught t plus omega naught tau plus theta plus omega naught t plus theta, that is cos A plus B, plus cos A minus B, cos of omega naught t plus omega naught tau plus theta minus omega naught t plus theta. Now it is equal to a square constant 1 by 2 constant. So taking outside from the expectation, a square by 2 expected value of cos omega naught t plus omega naught tau plus theta plus omega naught t plus theta, second term plus cos omega naught t plus omega naught tau plus theta minus omega naught t minus theta. Grouping this, we will get a square by 2 expected value of cos 2 omega naught t plus omega naught tau plus 2 theta plus cos omega naught tau. Now we are splitting the expected values to the two terms, that is the expected value of x plus y, which is equal to expected value of x plus expected value of y. So using that idea, we will get a square by 2 expected value of cos 2 omega naught t plus omega naught tau plus 2 theta plus a square by 2 the second term expected value of cos omega naught tau. Here cos omega naught tau is a constant. So expected value of any constant is nothing but the same constant, that is E of c, which is equal to c. Therefore expected value of cos omega naught tau is nothing but cos omega naught tau. So we will get a square by 2 expected value of first term cos 2 omega naught t plus omega naught tau plus 2 theta plus a square by 2 cos omega naught tau. So next what we are going to do is taking that cos 2 omega naught t plus omega naught tau plus 2 theta as y of t for our convenience. So these terms become a square by 2 expected value of y of t plus the second term as it is a square by 2 cos omega naught tau. Now we are using expected value formula. So a square by 2 integral 0 to 2 pi y of t f of theta d theta plus the second term a square by 2 cos omega naught tau. So substituting y of t here, a square by 2 integral 0 to 2 pi cos 2 omega naught t plus omega naught tau plus 2 theta into f of theta is nothing but 1 by 2 pi from equation number 1 into the theta plus a square by 2 cos omega naught tau. We know integral cos a plus b plus cx, which is equal to 1 by c sin a plus b plus cx. So using this formula, we will get a square by, so 2 pi is also constant taking outside, So we will get a square by 4 pi into integral value sine 2 omega naught t plus omega naught tau plus 2 theta by 2 lower limit 0 upper limit 2 pi. The second term plus a square by 2 cos omega naught tau. Now applying the limits, upper limit and lower limits, taking 2 outside, so a square by 8 pi sine 2 omega naught t plus omega naught tau plus 2 times upper limit 2 pi minus sine 2 omega naught t plus omega naught tau plus 2 times the lower limit 0 plus a square by 2 cos omega naught t tau, which is equal to a square by 8 pi sine 4 pi plus 2 omega naught t plus omega naught tau minus sine 2 omega naught t plus omega naught tau plus a square by 2 cos omega naught tau, which is equal to a square by 8 pi sine 2 omega naught t plus omega naught tau. Since we know sine 2 pi plus x, which is equal to sine x, same thing sine 4 pi plus x, which is equal to sine x, sine 2 sine of 2n plus 1 of pi plus x, which is equal to sine x. You know, n is any number, sine of 2n plus x, which is equal to sin x. N is any number. So 2n pi plus x is sin x. Here 4 pi plus x is also sin x. So that is why sin of 2 omega naught t plus omega naught tau. Second term minus sin 2 omega naught t plus omega naught tau plus a square by 2 cos omega naught tau. So in first term sin 2 omega naught t plus omega naught tau minus 2 omega naught t plus omega naught tau 0. So first term becomes 0. Second term as it is a square by 2 cos omega naught tau. So r xx of tau, which is equal to a square by 2 cos omega naught tau, which is a function of tau. This is our third equation. So from second and third, x of t, the random process x of t satisfies the condition for wide sense stationary, WSS. Therefore x of t is a WSS, wide sense stationary. Thanks.